Hello friends, we are doing problems on pressure and fluids, concise physics, class 9. Problem number 6. A simple U tube contains mercury to a SEM level in both its arms. If water is poured to a height of 13.6 cm in one arm, how much will the rise of mercury level in other arm? When you talk of YouTube, you're not talking of YouTube as in the video watching channel. We're talking of a YouTube. So let's try to draw a YouTube out here. So a simple YouTube is a kind of a tube, which is of the shape U. Okay, and out here we take mercury as gray in color, and so we can mercury like this. So that's initially there was just mercury out here. Okay, this was the level. We don't know what are the level, but we just it's in the same level, like liquids take the same level kind of a thing when connected. Then what you have done, we have poured some water on one side. We have poured some water on one side. Okay, since water is like lighter than mercury, it will float on water. It will not go into the next arm of the tube. Okay, this might be arm A and this might be arm B. So, and this height that's given is 13.6 centimeter. So what happens when you put water on one side? What happens? The mercury level on tube B will rise a bit. So let's say it has risen a bit, not much, because mercury is heavier than water, so lighter things cannot push a heavier liquid much, so it has risen up. So initially, so how do you really do this kind of a problem? The best way to do this kind of problem is to try to find out a point where the pressure is the same. So if we take this point and go directly to the other tube straight kind of a thing, so we get this point, right? So this is now the separation point on the tube A of mercury and liquid, and this is the same correspondence point on the tube B. So we can say that pressure at this location on tube A and pressure at this location on tube B are the same, because there is nothing but mercury out here. This is just all mercury. There is no other fluid. So the pressure will be at this point and at this point will be the same. So if you look at this pressure P, let's say it's let's say at this point the pressure is caused by what? This pressure is caused by this water level or this column of water, and pressure at this point is caused by nothing but this rise in mercury level. Okay, so this 2 point, the pressure got to be the same. Okay, so let's put this pressure as P1 at this point, and this is as P2. So now, using the formula of pressure, that is pressure is equal to rho into height of the liquid column, and G, because we know pressure of fluid depends on only two things: the height of the liquid column or the fluid column, and the density of that fluid for which the pressure is created. So if you find the pressure on P1, so P1 is nothing, because P1 is caused by on the tube A part because of the water level of 13.6 centimeter. We can put the rho of water density as 10 to the power 3, the height as 13.6, it's in centimeter, so you just convert it into meter, that is multiplied by 10 to the power minus 2 into G. G is not required out here because it will get cancelled out both the sides. So P2 is nothing but what is the cause of P2? P2 is nothing because of this height of this mercury column, so we can call it as H. Okay, so H of mercury. Okay, we call it as H in gray color H, so that denotes mercury. So what is the density of the mercury? Density of the mercury is 13.6 into 10 to the power 3 kg per meter cube into H into G. So we've told before, this pressure at this point and pressure at this point is the same, so P1 is equal to P2. Okay, so P1 is equal to P2. So equate this P1 equal to P2. What we might get is, I'm keeping the color same as the equation is 10 to the power 3 into 13.6 into 10 to the power minus 2 into G is equal to P2. P2 is nothing but 13.6 into 10 to the power 3 into H into G. Now a few things get cancelled out. First is G gets cancelled out because it's the same. Second, this 2 gets cancelled out. Another thing, 13.6 gets cancelled out. So what eventually remains with us is H is equal to 10 to the power minus 2 in meter, which is nothing but 1 centimeter. You multiply it by 100, so that's 1 centimeter. So our answer is the height or the increase of mercury level out here is 1 centimeter. But what does that mean? That means the pressure exerted by 13.6 centimeter of water column is equivalent pressure that is exerted by 1 centimeter of mercury column. Why is like what's special with this 13.6 and 1? Because we can see the density of mercury is 13.6 times the density of water. So since G remains constant for both the equation, the only thing that pressure depends upon is the density and the height. So if the height, if the density is 13.6 times, so obviously the multiplying factor, that is height, will be 13.6 times less. So that's the height of the mercury column, 1 centimeter, since the height of the water column was 13.6. So now if you have any doubts, if you couldn't understand any part of this problem, do send us your comments, your queries. We will answer it in future videos. Thank you.